So today we're going to be talking about your gain staging and signal to noise ratio, and I've made these quite crude um, pictures here to help explain it. Okay, so on any unit, be it an interface or a mixing desk, um, we're going to have to do what's called gain staging. What gain staging does is it ensures that the signal is both noise free and distortion free. So here on the first diagram, this is our volume level. On any electronic piece of equipment, we have little electrons that just bounce around mad when there's power. They exist right down the bottom of what we perceive as volume as noise. So these are all wee nasty wee electrons, and they sound like white noise, like sound. Um, if we turn it up too much, we're going to get distortion. So let's look. Here's a nice clean signal represented by this blue line. And as you can see here, it's been lifted loud enough where it's above the noise floor, and it's not been lifted too much or it's going to distort. So this will be the optimal signal to noise ratio. Now, if we brought it in and we made it too quiet, if we didn't apply enough gain at all, the signal would mix in here with all these free electrons down here on the noise floor. That's how we refer to this part here, the noise floor. When we would go to, let's say, turn it up in the compressor or turn it up in EQ or apply gain after it's went through the preamp, this would lift not only the signal but also the noise as well. Um, so here we are here. This is our signal at our gain stage, at our desk when we're applying the gain on the microphone input. And then we're mixing and we apply more gain after, and we apply gain through EQ or compression. What we're doing is we're applying gain to all that signal, so including the noise. So we're going to get a very noisy, very fuzzy type audio, which is not what we want at all. So we have to make sure when we're inputting our signal into a desk or interface that we lift it enough up above that noise floor using our gain function. Now, if we do that too much, what we're going to get is distortion. Ta-da! And you can see here on the waves that when they're reaching the sort of highest volumes here, they've got nowhere else to go because the distortion ceiling, that's what we call this part here, the distortion ceiling, is going to cut them off. It's a ceiling. There's nowhere else to go. So the top of the heads get chopped off. It's quite aggressive, and then we get the sound of distortion on our signal. So we definitely don't want that. So when we're bringing a signal into a desk or an interface, we want to make sure it has enough gain to be in above the noise floor, but not too much gain where it distorts. And that's your perfect textbook answer for signal to noise ratio. Let's just look at a VU meter. So you'll recognize this meter from Logic, from the studio desk or an interface, etc. Here we got the digital system and the analog system on the right. You can see here on the digital, once it passes 0, it distorts. Here you get plus 24 on an analog system. Here's where it's going to start peaking, where you're going to start seeing your red line. I would meter to around here, just this white line here. And what we're doing is we're allowing enough headroom. That means if we apply any more extra gain, that we've got a little bit of a safety room here just for the signal to peak up. And way down here, we have the noise floor. So if I brought, say, a microphone in and didn't apply probably hardly any gain at all, it would become very, very noisy and sound almost like a really bad mobile phone recording or something like that. So what we want to do is we want to make sure we stay away from here and we stay away from here. Usually on an analog system, you'll be going to around 0. Maybe on a digital system, you want it to be about minus 20. Handily enough, on our desk, we've actually got the 0 VU line across our desk to show us exactly where we should be metering to. basically, as a rule of thumb, you want it to be going under the yellow, but you don't want it to be going under the red, and you know you'll be safe.